Hi, in this part I'll quickly show the quarter setup for the timer design. Here I have my quarters project, my first HPS FPGA open for E1 SoC board. This is the top level module. Yeah, this is the platform designer um, that connects the HPS to the FPGA logic. You can see PIO hex 0 to hex 5 that drives 7 segment displays. Hex 0 through hex 5 are each connected to PIO separately, and these PIOs map to the lightweight HPS to FPGA base addresses. You can check here, they're from 0, 1, 2, 3, 4, 5, and they have end address as well. These lets the ARM processor update the 7 segment displays just by writing those memory mapped addresses in my C code. The hex outputs are also assigned to the correct D1 SoC pins in the pin planner. So each hex 0 to hex 5 segment lines is wired to the board connections. After setting this up, I generated the HDL from platform designer. So I've already generated it. I'll show you. That step also creates the HPS handoff and header files like SOC and HPS register definitions, which I include later in the HPSC program. So click on show instantiation template. You can see these lines over here. So just copy these from this file, instantiation template. Now in the GHRD top module, go to uh, here and paste the uh, thing what you have obtained from that instantiation template and change the nomenclature for readability. And also check here, we have got all the 6 output wires which are required for 7 segment display. I've compiled the whole project, and this is the compilation report where you can check the logic utilization like ALMs, ALUTs, and IO pins and registers, DSP blocks, and everything in a summary. Let me go to timing analyzer. Update timing netlist. I'll show you the Fmax summary. So maximum it can go up to 1084 megahertz. And reports so the delay is 24.633 nanoseconds. So after this, the compilation report, you can see that the build is successful, and the compilation produces s.sof file, which is a bit string I download for FPGA before running the HPS timer application. Let me open this too. It's here. As soon as you click on start, it will be uh, dumped into the FPGA board. I've already loaded this soc file. For the software side, I used a small shell script which is already given. So how did I run it? Okay, well, so I have cd to the respective directory, and here we can find generate hpsqsys header dot shell script. I've run it, compiled, and after this we can check the header files have got updated. um, this line shows that creating macro file hps 0 dot h. Show you where it is to. So it will be updated over here. I've copied and pasted it in hps.c. Let me open this and show you how. I've already compiled it. So here you can see the respective header files are updated. The ports related to hex 5 to hex 0 are updated in this header file 43210. That's it. Yeah, after compiling, you'll get this my first HPS FPGA. I'll show you in the terminal what all commands to be used. After running the shell script, now we need to compile it. So cd to the respective folder where you can find .h and .c and make file, and type make. Yeah, for knowing if it is compiled or not, type ls. You can find these two files generated after compilation. To find out how much is the size of the compiled file, you can just give this command. It is 16 kilobytes. Now after this you can just copy that to the pen drive and plug it into FPGA board. The next steps I'll be explaining how does it work on FPGA. Now I'm running the HPS application from the root directory of the D1 SoC board. As you can see on the terminal, the program has started successfully. The HPS is generating a real-time clock and the software sending the values to the FPGA through the lightweight HPS to FPGA bridge. So let me run this first. The screen will be shut down. And in Cortex, let me start this. Now you can check the timer is on. This will change to minutes and this will be changing to hours. Yeah, now it has changed to 1 minute and the seconds timer is again counting. Here is a small clip where the 7-segment display is displaying the hours, minutes and seconds. Thank you.